My name is Brian. I'm with Beaded. We are a local tech company. We actually develop software and hardware at the same time to solve environmental sensing solutions around the world. Pretty simple, actually. Mostly we measure temperatures in permafrost and underneath infrastructure and try to help guide the development of resilient infrastructure. We had for the hackathon, we had a problem. We were trying to innovate the way that we make cables. So these are real quick examples of cables that we make. Here's one that we use for ice roads. Which camera was that? Right there.
It's this one.
This guy. Oh, okay. For Carabanks. So this one right here, you can see has a number of blue nodes on them. Each of those blue nodes starts out as a chip on a printed circuit board that's spliced in, and we're looking, our mission is to automate the manufacture of these things. And if we do that, we have a problem, which is we do not know the order that the sensors are built into the cable. So Jeremy here worked with us this weekend to come up with a novel way of quickly sorting out which sensors, what order they're in, through software and with a little bit.
So the idea is that eventually they'll have some mechanical way to heat up each sensor individually. So I'm just going to do it manually to demonstrate. So they would heat them up in order, and while heating them up in order, we're detecting which ones increase in heat, and then logging that in order. And then when it's done, it spits out a report with a list of all the sensor IDs in order.
And maybe we'll do like the really low-tech screen share if you want to just flip the laptop around and show them the output.
Okay.
And this is the guy right here?
Yep. So you can just pick that up and...
Oh, cool. I'll be cameraman.
So I detected one of them. Here's the second one. It should beep when it detects it. If you put it at 2 degrees Celsius, it has to change before it will detect it.
Should be faster than that, huh? Yeah, you can see it right there. I don't see anything changing. Oh. That beep.
Yeah.
That beep indicates that was our first, just out of the gates, like, hey, we got to give some sort of audio-visual way for a technician or a machine or something to say, okay, move on to the next one. And for those that are in Fairbanks, I don't know if you can see, but it says found 3, and so we have 5 total. And so just sequentially, Jeremy is going through and grabbing the sensor, and it's a temperature sensor, so it's just getting pulled every second or every couple of seconds, and then we're watching that as it rises. We've got a heat gun. We've got ideas of tubing cables on reels and going from reel to reel and having this automated with a stepper motor, or maybe an audio, like an optical eyeball to look for cable sensors. Oh, yeah, that's it. We're gonna go like this, and this is Jeremy putting his fingers on the cable. All right. And that is a happy sound. That's a sound that the test completed, and they found the number of sensors that we said was there originally, and now we know the order of the cable.
So the project started off, this device is something that they already have. It provides the data for anything connected to it in an XML feed. And we just take that XML file, we convert it to JSON, import it into the application, and then we're just looking at the data every time we do that to look for the sensors that are increasing by 2 degrees from their start state. And that's basically it.
Yeah, we're going to put this in the wild and put it in production and see if the threshold needs to change, the way that we decide what the starting state is, or when to decide if this is the sensor impact of interest can change. It could even be getting colder. We could run the cable from the warehouse into a pool, ice bath, or something like that. There's a lot of things we can do now that we couldn't do before. Thank you.
Brian, I did have one question for you.
Yeah.
How is why did you have to use that NetGate adapter, and how is the signal being transmitted up the cable and over to that device?
Oh, up the sensor cable?
Yeah.
So these sensors are what they call smart sensors, but they're not very smart. So they have a real low-level serial communications interface. It's an industrial protocol, not very common. And so we need a logic translator and also a controller, a power circuit. This box provides that, so it's essentially a master to these slave units, and then it mounts these sensor nodes onto an Ethernet network. And so that's how this box works.
And then can you give an example of where you might deploy one of these cables?
Yeah, these cable. So this type of system, or even using this very same box, would go up in, and does go in a lot of locations in rural Alaska where there's infrastructure projects. So it's typically school additions, airstrips, water treatment plants, libraries, clinics, post offices, your basic nuts and bolts of civilized society. And so, these are places over permafrost. I should have said that we're trying to maintain warm buildings just like this over frozen ground. And that's where some instrumentation, measurement, and monitoring comes into play.
Cool, thanks.
Yeah, thank you.